Sioux City, got emergency for you. All right. I got a United aircraft coming in, lost number 2 engine, having a hard time controlling the aircraft right now. He's at a 29,000 right now and descending to Sioux City right now. He's east of your VOR, but he wants the equipment standing by right now. Radar contact.
Okay, so you know we have almost no controllability. Very little elevator and almost no aileron. We're controlling the turns by power. I don't think we can turn right, but I think we can only make left turns. Well, we're starting a little bit of a left turn right now. I mean, we can only turn right, we can't turn left.
United 232 Heavy, understand, sir. You can only make right turns?
That's affirmative.
United 232 Heavy, safe souls on board and fuel remaining.
We have 37.6 fuel and we're counting the souls.
Roger. United 232 Heavy, Sioux City.
We have no hydraulic fluid, which means we have no elevator control, almost none, and very little aileron control. I have serious doubts about making the airport. Have you got someplace near there that we might be able to ditch? Unless we get control of this airplane, we're going to put it down wherever it happens to be.
United 232 Heavy, roger, standby 1. United 232 Heavy, say again.
Here's the airport to us now as we come spinning down here.
United 232 Heavy, Sioux City Airport's about 12 o'clock and 36 miles.
Okay, we're trying to go straight. We're not having much luck. 232. We're going to try to put it in Sioux City.
United 232 Heavy, understand you're going to try to make it into Sioux City? There's no airports out that way that can accommodate you, sir.
Okay, we'll head for Sioux City. We got a little bit of control back there. Only the runway.
United 232 Heavy, the airport, the runway is 9,000 feet long, 150 foot wide.
Okay, thank you.
And United 232 Heavy, did you get the souls on board count?
Remember, I tell you right now, we don't even have time to let go to call the gal.
Roger.
292.
Roger, thank you. United 232 Heavy, do you think you'll be able to hold about a 240 heading?
Yeah, we're trying to turn to it right now.
Roger. When you get turned to that 240 heading, sir, the airport will be about 12 o'clock and 38 miles.
Okay, we're trying to control it just by power alone now. We have no hydraulics at all, so we're doing our best here.
Roger, and we've notified the equipment out in that area too, sir. The equipment's here on the airport standing by, and they're sending some out to that area.
Yeah, 232, we're going to have to continue one more right turn. We've got the elevators pretty much under control within 300 or 400 feet, but we still can't do much with the steering.
United 232 Heavy, Roger, understand you do have the elevators possibly under control. We've got to hold altitude.
Negative, we don't have it. We are better, that's all.
Roger. United 232 Heavy, there's a small airport at 12 o'clock and 7 miles. The runway's 4,000 feet long there.
Hey, I'm controlling it myself right now. As soon as the captain gets back on, he'll give me a hand here. He's talking on PA.
Roger.
Okay, United 232, we're starting a left turn back to the airport. Since we have no hydraulics, braking is going to really be a problem. I would suggest the equipment be towards the far end of the runway. And I think under the circumstances, regardless of the condition of the airplane when we stop, we're going to evacuate. So you might notify the ground crew equipment that we're going to do that.
United 232 Heavy, Wilco, sir, and if you can continue that left turn to about a 220 heading, sir, that'll take you right to the airport.
20 now.
United 232 Heavy, you're going to have to widen out just slightly to your left, sir, to make the turn to final, and also that'll take you away from the city.
Whatever you do, keep us away from the city.
United 232 Heavy, been advised there is a 4-lane highway up in that area, sir, if you can pick that up.
Okay, we'll see what we can do here. We've already put the gear down, and we're going to have to be put on something solid if we can.
United 232 Heavy, roger. Can you pick up a road or something up there?
We're trying. It's still anywhere from 2,000 feet up to 1,500 down now in waves.
Roger. Come on. United 232 Heavy, can you hold that heading, sir?
Yeah, we're on it now for a little while.
United 232 Heavy, roger. That heading will put you, currently 15 miles northeast of the airport. If you can hold that, it'll put you on about 3 mile final.
Okay, we're giving it heck.
United 232 Heavy, roger. The airport's currently at your 1 o'clock position, 10 miles. And United 232 Heavy, if you can't make the airport, sir, there is an interstate that runs north to south to the east side of the airport. It's a 4-lane interstate.
We're just passing it right now. We're going to craft the airport.
United 232 Heavy, roger. And advise when you get the airport in sight.
Got the runway in sight. We'll be with you very shortly. Thanks a lot for your help.
United 232 Heavy, the wind's currently 360 at 11, 360 at 11. You're cleared to land on any runway.
You want to be particular and make it a runway, huh? Say the wind one more time, please.
Wind 010 at 11.
Okay, we're all three talking at once. Say it again one more time.
010 at 11, and there is a runway that's closed, sir, that could probably work too. The south, it runs northeast to southwest.
Pretty well lined up on this one, or I think we will be.
All right.
Get.
United 232 Heavy, roger, sir. Yeah, that's a closed runway. That'll work, sir. We're getting the equipment off the runway, and they'll line up for that one.
How long is it?
6,600 feet, 6,600, and the equipment's coming off. At the end of the runway, it's just a wide open field, so the length won't be a problem.
Okay. Isolate that.
On July 19, 1989, this accident took 111 lives. But more importantly, 184 people survived. According to Captain Al Haynes, the pilot in command of the crippled DC-10 aircraft, the very high survival rate was possible only because of the team effort of the groups involved in handling the emergency. Captain Haynes refused to take the full credit for saving the lives of the 184 surviving passengers. Instead, he emphasized that he was only one of thousands who assisted in the survival effort. Of course, it took a highly skilled pilot to coordinate the team, but all pilots should be aware that the same resources and assistance provided to United Airlines Flight 232 is available to us as well. Many resources are available on request. In years past, the term cockpit resource management referred to the pilot's ability to logically arrange his charts, plotters, and other required items in the order of their expected use. It seemed to limit the pilot's resources to only those in the physical cockpit. It is so much more, as we will see. According to Dr. Alan Deal, Human Performance Technical Advisor to the Air Force Safety Agency, investigations into the causes of aviation accidents have shown that judgment errors associated with cockpit management are a contributing factor in the majority of the incidents and accidents. Long-term research has demonstrated that these events share common characteristics. Many problems encountered in flight have very little to do with the technical aspects of operating an aircraft. Instead, poor decision-making, ineffective communication, inadequate command actions, and poor task or resource management are associated with the problems. Pilot training programs have historically focused almost exclusively on the technical aspects of flying and on the individual's piloting skills. The training did not effectively address resource management issues that are fundamental to a safe flight. Perhaps a good definition of cockpit resource management would be the effective use of all available resources needed to complete a safe and efficient flight. These resources may include assistance from other individuals, the capabilities of airborne or ground equipment, or the dissemination of information available to us. Effective cockpit resource management, or CRM, is much more than keeping a well-organized cockpit. It involves an awareness and knowledge of the resources that are available to assist pilots in the decision-making process. CRM encompasses everything we do to achieve safe and efficient flight operations, regardless of whether we normally operate single pilot or as a member of a multi-pilot crew. CRM is a valuable tool in developing the team concept in our flying activities. Because flying is a combination of events that require us to make a continuous stream of decisions, it is vital for pilots to develop this team approach to address both the expected and unexpected events that occur in the course of a normal flight. For the next few moments, let's take a look at how effective cockpit resource management can enhance safety for both multi-pilot crews and single-pilot operations. We will also take a brief look at how instructors and pilot examiners can promote the use of CRM techniques in the course of everyday flight training and testing. In recent years, CRM training has received widespread attention in the training programs of the nation's air carriers. This training was mandated by the FAA through the Federal Aviation Regulations. Although the average general aviation flight department is smaller in scope and size than that of its air carrier counterpart, they share similar operational problems. For this reason, CRM training and procedures should be an integral part of general aviation training programs as well. Effective CRM techniques encompass not only those areas of interest to the individual pilot, but equally important is the human interactions of individuals during multi-pilot operations as well. CRM helps to bring together the humanware, software, and hardware to achieve safe and efficient flight operations. Because individuals bring varied backgrounds and levels of experience to the cockpit, it is important for us to realize that no one individual has all the answers to the numerous decisions that are required in the course of everyday flight operations. Effective problem solving requires that all information, regardless of its source, be considered. A primary goal of cockpit resource management techniques is conflict resolution, or problem solving. An essential part of this practice is communication, or an open transfer of information between crew members. The ability to communicate effectively with other crew members is a vital link in the CRM process. Let's take a look at how CRM techniques can be used to overcome many of the barriers to effective communication and to establish open communication between crew members. First, a complete briefing is an essential part of our pre-flight duties. This provides an opportunity to develop the team concept and encourages participation from all crew members. This allows the pilot in command to establish standard operating procedures as well as safety and operational issues. The pilot in command can also take advantage of this time to address crew responsibilities as well as duties of the flying and non-flying pilot. It is important to remember that all crew members, not just the flight deck crew, should be included in this discussion. Secondly, it is important to keep all crew members in the decision-making loop. Participation by all crew members in the decision-making process should be encouraged. This allows each crew member to share in overall progress of the flight and to maintain his or her situational awareness. When all input is considered and a decision made, it should be clearly stated and acknowledged by each member of the crew. Resource management in the cockpit also should involve how those resources are being used. Workload management is an important consideration in the CRM process. This allows for the crew responsibilities to be established in such a way as to be more evenly distributed. The pilot in command can play an important role in minimizing the potential of excessive workload on crew members by prioritizing the tasks to be accomplished and delegating the tasks evenly among crew members. Each crew member should actively monitor activities in the cockpit to maintain their situational awareness, as well as to monitor the workload level of other members of the crew. We have reviewed several examples of good cockpit resource management practices. It is just as important to point out, however, what CRM is not. FAR 91.3 states that the pilot in command is directly responsible for and is the final authority as to the operation of that aircraft. CRM is not an infringement on that authority, rather a tool to assist the pilot in fulfilling his obligation to carry out his flight operations in a safe and efficient manner. CRM encompasses the team-building approach to problem solving. Better teamwork results in better communication, crew coordination, and problem solving. Working together to accomplish multiple complex tasks safely. That is what cockpit resource management is all about. As anyone knows, the multi-pilot cockpit is the ideal situation. However, many of us fly small general aviation aircraft that are designed for single pilot operation. In this situation, you may be the only one in the aircraft who knows anything about flying, weather, or communication. However, you are not alone. There are many resources available to you. They range from the many publications, such as charts, airport facility directories, and the AIM, to the various FAA air traffic facilities on the ground along your flight path. Let's look a little more closely at some of them. One of the first things available to you are the many safety seminars like this one that are held by the FAA and other safety-minded aviation organizations. Anytime you have the chance to enhance your skills through additional training, you have just added another resource to your bag of aviation tools. Next, flight information publications are a valuable source of help. It just takes one time to need a current chart for a good frequency before you realize this. These are available from a variety of groups such as AOPA, Jepson-Sanderson, and NOAA. The Airman's Information Manual is another good source of valuable information. You should realize that the information in the AIM is constantly under revision, and your copy should be current. How up are you on your ability to get up-to-the-minute weather information? One of the biggest changes underway is the consolidation of the flight service stations into the automated flight service stations. New technology, such as computerization of information, is allowing for new services to be offered. HIWAS, AWOS, TIBS, FastFile, and a host of other resources are available to assist a single pilot in the safe operation of an aircraft. Do you know what these are? Do you know how to effectively use them? If you don't, then contact your local AFSS to set up a tour to learn what is available. Air traffic control is another resource that is sometimes overlooked because of fear of the radio, or sometimes the pilot doesn't want to appear foolish. Some of the great resources available include radar traffic advisories, automatic broadcast of SIGMETs, and flight following, workload permitting. In emergencies, AFSS have the DF Steer, which can be used to locate aircraft and offer assistance in reaching a safe landing site. ATC radar facilities can also be used in an emergency. A great resource available in the aircraft is the Pilot Operating Handbook, or POH. Anytime you are in an aircraft that is new to you, or in which you have less than 10 recent hours, you should take a quick look over the material in the POH so that if you need to know something in a hurry, you can get to it quickly. Be familiar with the equipment installed in the aircraft. This is an area of growing importance as the speed and sophistication of aircraft increases and availability of navigational equipment such as LORAN and GPS increases. Many of us rely on autopilots. They too are a resource. Do not overlook the value of local knowledge at unfamiliar airports. Many transient pilots have come to grief because of a local hazard that was overlooked or that they were not aware of. This sort of help is available from the FBO and local pilots. Probably you have used all of the things that I have mentioned, some more than others. You have done this without conscious thought that you were using resources. I would suggest that you think in terms of using all the items mentioned as a single concept: cockpit resource management. By unifying the resources, you will greatly enhance the safety of operation of your aircraft. From the previous discussions, you've seen examples of how effective cockpit resource management practices can be in both single and multi-pilot operations. It should come as no surprise, then, that CRM is also beneficial during the course of basic and advanced flight training, as well as during the FAA practical test. An applicant for an airman certificate or rating is expected to display good decision-making skills by effectively using the resources available to him. These resources may include ATC or AFSS services, aircraft avionics and systems, charts and publications, and yes, even the pilot examiner. The examiner is expected to set the guidelines for the flight prior to boarding the aircraft. The examiner is a professional and should set the tone for CRM practices to be used throughout the flight. The examiner will, however, leave room for the applicant to display and expand his or her own CRM skills during the flight. Let's listen in on a portion of this examiner's pre-flight briefing. See if you can recognize the areas relating to proper CRM practices.
First of all, you understand that you are a pilot in command on the airplane.
Yeah.
I'm not free to give advice. I'm strictly a passenger for the flight today. I'd like for you to call out to me any observed traffic that you see. I'll do the same thing for you. Make sure we both know who's operating around us. Let's talk about emergencies for a minute. If I give you any simulated condition, I'm going to announce it. If we have an actual emergency, remember you are a pilot in command. You handle the appropriate procedures. I will not take over the aircraft unless I think either what you're doing or failing to do is jeopardizing our safety. I'd also like to remind you of the FAA's discontinuation policy. You may stop a check ride at any time without any prejudice that it's going to be a tougher exam because I have to come back out. Any questions on these policies at all?
No.
Okay.
Although the use of proper CRM techniques is very beneficial to the examiner, it is essential that the applicant be comfortable with them as well. The FAA Practical Test Standards states that the examiner will observe that equipment and materials are well organized and properly arranged, and that occupants are briefed on the use of safety equipment and emergency procedures. The applicant can establish proper CRM techniques early during the practical test by making specific requests of the examiner. Let's listen in again on our practical test applicant as he initiates good CRM procedures with the pilot examiner.
Todd, those are the practices I want to use today while we conduct the flight. Do you have any questions or additional comments?
Yeah, if I could, I'd like to ask that you assist me during clearing turns for seeing and avoiding traffic.
Okay.
Also, when I'm under the hood, I'll let you know which direction we're turning prior to making the turn.
That's a good idea.
And if air traffic control calls out traffic and you don't see it and I don't see it, I'll ask for vectors around traffic.
Okay.
Also, when we have an emergency, I'd like to ask you to pull out the checklist, turn to the appropriate page, and then squawk 7700.
Todd, don't you think that would be the pilot's responsibility to find the appropriate check?
Obviously, certain requests of the examiner would not be appropriate. If a request cannot be honored by the examiner, he will specify at that time why he cannot comply with the request. It is obvious that good CRM practices are an important part of piloting skills, and one that is being evaluated on the practical test. Examiners set the tone for the flight, and the applicant should continue by displaying the judgment developed during their flight training experience. As you can see, we can all benefit from good CRM practices. It only requires some preparation and the desire to participate in open communications. There must always be a pilot in command, but all those involved in the flight must be vigilant and participate.
Welcome to the Federal Aviation Administration's Avoiding Airplane Upsets video. This video is a product of the FAA's Safer Skies Agenda, a renewed commitment between FAA and industry to develop educational programs designed to reduce the number of aviation accidents.
Hi, I'm Sean Elliott, the President of the National Association of Flight Instructors. One of the most important missions of our organization is safety. Most flight instructors define safety as minimizing risk through quality training and education. The members of the IAC, or International Aerobatics Club, share this definition. The IAC is a competitive aerobatics organization, but more importantly, its focus on safety affects all types of pilots flying all types of aircraft. The IAC has enjoyed an outstanding safety record over its 30-plus years of aerobatic competition. It's because of this expertise, along with the educational focus of NAFI, that the FAA has commissioned the IAC to develop the program you're about to see. I'm certain you'll find the program both informational and educational, but most importantly, I'm certain you'll find it of value in making you a safer pilot.
Mike Goulian can boast such accomplishments as being named U.S. Unlimited National Champion, being a 3-time member of the U.S. National Aerobatic Team, and securing multiple medals at the World Aerobatic Championships. Goulian is also a certified flight instructor, specializing in aerobatic instruction. In his spare time, he amazes crowds with spectacular airshow performances. Julie Savage earned her certified flight instructor's rating while completing her bachelor's degree at Southern Illinois University. Julie has competed successfully on the Precision Flight Team at SIU, and in 1999 won top female pilot in the nation at the National Intercollegiate Flying Association Safety and Evaluation Conference. Julie currently flies for American Eagle Airlines based out of Chicago O'Hare Airport. In her spare time, she serves on the foundation board of the Experimental Aircraft Association.
The FAA has identified 6 categories into which a large majority of general aviation accidents can occur. Number 2 on that list is loss of control. The loss of control associated with an unintentional airplane upset has become a popular topic in recent years.
It certainly has. So much so that several airlines and corporate flight departments have added upset recovery training to their recurrent training programs, and even NASA funded a study to determine the potential benefits of hands-on upset recovery training.
In this program, we'll take a closer look at 3 classic airplane upset scenarios. Each is associated with rolling, possibly to high angles of bank. All are accident scenarios that continue to get pilots into trouble. We'll also discuss strategies to help you recognize and avoid situations that can lead to these or similar roll upsets.
But first, let's define what we mean by a roll upset. For our purposes, a roll upset involves any uncontrolled or uncommanded change in your airplane's bank angle. As the bank continues to increase, it usually becomes more and more difficult to maintain the desired heading, altitude profile, airspeed, or attitude.
For example, if you are intending to cruise along in wings level flight at a constant altitude, but the airplane suddenly rolls over to 90 degrees of bank, you are experiencing a roll upset. With this in mind, let's look at our 3 scenarios. Roll upsets have been with us since the beginnings of power flight. These potentially disastrous scenarios have been, and continue to be, concerns that we, as responsible pilots, must deal with.
The first roll upset scenario develops from a botched turn and results in an uncontrolled descending spiral. Although the process leading to this upset can start from any bank angle, it's usually associated with steeper bank turns. While attempting to turn, the pilot unintentionally allows the bank angle to increase without simultaneously increasing back elevator pressure. The pilot is slow to react as the nose of the airplane drops below the horizon.
Airspeed increases noticeably as the altimeter and vertical speed indicator show a rapid loss of altitude. Meanwhile, bank angle remains high due to the natural overbanking tendency of the spiraling airplane. Reacting now to the accelerating nose-low attitude, the pilot instinctively pulls back on the elevator control, trying to get the nose up. Unfortunately, this action only tightens the descending spiral.
Frozen on the controls, holding aft elevator, the pilot is unable to recover from the spiral. Prior to ground impact, the airplane may suffer structural failure as airspeed and G-load design limits are exceeded.
The next scenario involves a weather-induced upset. Perhaps as a result of turbulence in the atmosphere, mountain waves, or thunderstorm activity. Flight into icing conditions poses multiple hazards to the pilot as well, including the potential for a roll upset, even if the airplane is equipped with an anti-ice system.
The pilot is flying in instrument conditions on the autopilot. The weather is conducive to icing, with visible rain and freezing conditions. Large droplets splatter on impact with the windshield. Small streams of water streak across the side windows. Ridges of ice begin to form on the wings ahead of the ailerons. Masked by the autopilot, the pilot is unable to sense an unusual vibration in the control wheel. The autopilot disengages as the ailerons deflect suddenly to the control stop. Caught off guard, the uncommanded roll causes the pilot to pull back on the elevator control as the airplane rolls inverted. In the third upset scenario, air traffic control sequences a small airplane behind a larger, heavier aircraft miles ahead. The pilot is cleared for the visual approach straight in and is cautioned about the possibility of wake turbulence.
Ambient lighting conditions, however, are such that the pilot of the small airplane is not yet able to see the traffic ahead or its flight path. The winds are light with barely a hint of a quartering tailwind. The air is smooth. Assuming the heavy traffic is flying precisely along the 3-degree VASI glide slope, the pilot of the small airplane sets up to do the same. The pilot begins to fixate on the approach.
As the approach continues, the pilot encounters a bump in the air, followed quickly by another. Then the airplane rolls sharply beyond 90 degrees of bank. The pilot's delayed reaction is a timid attempt to apply opposite aileron as the airplane rolls inverted. The unusual attitude, sudden loss of altitude, and loosely secured seatbelt cause the pilot to pull back on the elevator control.
These accident scenarios actually share a number of common traits. In each case, the pilot did not recognize warning signs until the scenario turned into a full-blown unusual attitude.
The pilot's situational awareness was compromised prior to each roll upset as well.
Corrective actions either were initiated too late or were not applied fully to counteract the increasing angle of bank.
And in each case, the pilot's natural instinct to pull on the elevator control aggravated the situation and detracted from the pilot's ability to apply corrective aileron.
Pilots use the terms roll and bank interchangeably to describe how the aircraft moves about its longitudinal axis. The longitudinal axis is an imaginary line drawn from the nose of the aircraft through the tail.
And we roll about the longitudinal axis usually using the ailerons. And when we use the ailerons to roll, we actually are changing the shape of the wing.
By deflecting the ailerons, we are changing the chord line. The chord line is also an imaginary line that runs from the leading edge of the wing through the trailing edge. When we change the chord line in relation to the relative wind, we are creating an angle of attack.
When banking in normal, unstalled flight, the upward deflected aileron, the aileron on the same side as your roll input, tilts the local chord line forward, instantly decreasing the local angle of attack. This results in a decrease in the net lift on the up aileron side of the airplane.
On the other wing, the downward deflected aileron tilts the local chord line back, instantly increasing the local angle of attack. The net lift on the side of the airplane increases. It's this difference in lift that causes the airplane to bank in the direction of your aileron input. How fast an airplane rolls depends on several factors, including the length of the wing, the airspeed, and the amount of aileron applied.
For example, a high-performance aerobatic airplane may be capable of roll rates as high as 360 degrees per second, or faster, with very little effort on the controls and little loss of altitude.
Non-aerobatic airplanes, by comparison, tend to bank considerably slower and usually with more effort, especially when the airplane is in slow flight.
But it's not always necessary for the pilot physically to apply the ailerons for an airplane to roll. Environmental agents such as icing and wake turbulence can induce changes in bank angle as well.
Surface winds are reported as light. The air is smooth. Conditions are ideal for strong vortices to linger. The pilot is unable to see the large traffic ahead, but assumes it's flying along a 3-degree glide slope. The airplane suddenly rolls. Surprised and unable to stay securely in the seat, the pilot pulls back on the elevator.
Again, the best overall strategy is to avoid these roll set scenarios in the first place. Remain alert in the flight environment, heed the warning signs, and be prepared to react decisively should the airplane deviate from controlled flight. Shallow the bank as soon as you lose precise control over a turn. Never fly an airplane into known icing conditions if it's not approved for such flight. Turn off the autopilot and request immediate assistance at the first indications of icing. Give yourself plenty of separation from heavier aircraft. Separation is your responsibility as pilot in command. Don't tolerate uncommanded changes in bank angle either. As soon as the bank strays from your intended angle, even if it's only a little, apply whatever aileron and coordinating rudder is necessary to stop it, and avoid pulling aft on the elevator in the process.
The exercises we are about to describe can be dangerous. It is imperative that you receive competent instruction on the proper procedures involved. Call your flight instructor for a dual session to practice these routines. Do not try them on your own without a check flight.
Be sure to perform clearing turns before and while practicing the following training exercises. And as the pilot in command, be sure to adhere strictly to the operating limitations listed in your airplane's flight manual and posted on cockpit placards. Here's an excellent exercise that not only will improve your aileron and rudder coordination, but also will allow you to explore the range of aileron available in your airplane. In the practice area, set your airplane in a comfortable, slow cruise configuration at an airspeed below the published maneuvering speed. Look over the nose at a point on the horizon. Smoothly apply left aileron and a small amount of left rudder. Roll to 30 degrees of bank, then smoothly apply right aileron and some right rudder. Bank continuously from side to side. Focusing on the aileron as your primary input, rudder actions should be smaller by comparison. Use just enough rudder to keep the nose of your airplane on the reference point. As your skills improve, increase the bank angle to 45 degrees. Begin applying more and more aileron as you roll from side to side. Apply rudder simultaneously, but only as needed. And avoid inadvertently pulling aft on the elevator during the exercise. See if you can eventually apply full aileron while banking from side to side, keeping the airplane on heading and on altitude. A variation of the first exercise involves performing a level turn after establishing the bank. As before, set the airplane in slow cruise below maneuvering speed. This time, pick 2 reference points on the horizon, one over the nose and one off your left wingtip. Roll left to 45 degrees of bank without turning. The instant you reach the target bank angle, quickly neutralize aileron and rudder inputs. Then smoothly apply just enough back elevator pressure to pull the nose along the horizon in a level turn. Upon reaching your other reference point, completely release back elevator pressure to stop the nose on that point. Next, apply coordinated right aileron and right rudder while holding your new heading. Roll to 45 degrees of bank, neutralize aileron and rudder inputs, then pull the nose back to your initial reference point in a level turn. Upon returning to your original heading, release back elevator pressure first, then roll to wings level. Repeat the exercise, each time striving to add more and more aileron when changing the bank angle. Keep your aileron and elevator actions completely separate from each other. Be sure to return aileron and rudder exactly to neutral before applying aft elevator. And return the aft elevator completely to neutral before applying aileron and rudder. Remember, aileron is a primary input here. Rudder and elevator actions are relatively small by comparison. If the nose drops below the horizon and airspeed increases during the exercise, immediately release back elevator pressure and roll back to wings level. Our last exercise is a controlled spiral. Starting from the same slow cruise configuration, roll to 30 degrees of bank. Reduce some power and begin a descending turn. Maintain a constant airspeed down to a target altitude. Try spiraling at 45 or even 60 degrees of bank as well, keeping the airspeed constant throughout the descent. If at any point the airspeed begins to increase, reduce the bank angle right away. Practice the recovery technique for an unintentional spiral when you reach your target altitude. Reduce power to idle, release back elevator pressure, roll to wings level using coordinated aileron and rudder, then return to level flight. No matter how much flight time you have, don't be embarrassed if you're uncomfortable with turbulence or the prospect of encountering an airplane upset. And don't hesitate to get some instruction if you don't feel competent to practice the exercises we've recommended.
Additional dual instruction, either as part of your next flight review or the FAA's Wings program, can go a long way toward turning your anxiety about unusual attitudes into renewed confidence. Additional flight training can improve your situational awareness as well.
2 resources readily available to help you locate instructors and flight schools capable of safely exploring an airplane's envelope with you are the National Association of Flight Instructors and the International Aerobatic Club. Both are divisions of the Experimental Aircraft Association. NAFI maintains a list of certified and master flight instructors who are dedicated to giving professional instruction. The IAC annually publishes a directory of aerobatic schools. The IAC also offers a complete line of books and videos specifically addressing all-attitude flight. Additional resources include the Avoiding Spins videotape, available from the FAA, the FAA Advisory Circular number 91-51A, effective icing on airplane control and airplane de-ice and anti-ice systems, the FAA Advisory Circular number 90-23E, Aircraft Wake Turbulence, and the pamphlet Wake Turbulence, and the FAA's Wake Turbulence Training Aid, available through NTIS, which includes a report, videotape, and CD-ROM.
Make use of these and other resources and never stop being a student. Strive to learn all you can about the flight environment while staying current with the exercises that we've described. Know the limits of your own airplane, but most importantly of your own skills.
Exercise good judgment and remain situationally aware, especially when flying near the ground. Get some dual instruction once in a while and learn to recognize the warning signs preceding a loss of control.
After viewing this program, perhaps you have gained valuable insights that will make you a better and safer pilot. Don't stop there. Take the next step. For information on expanding your flight envelope as a pilot, consider joining the IAC. IAC's website can be found at iac.org. If you're a certified flight instructor and would like to expand your abilities as a quality educator, consider joining NAFI. NAFI's website can be found at nafinet.org. Always from the right seat, This is Sean Elliott saying thank you for your interest in safety.
This video was the result of the FAA's desire to tap into the practical knowledge of pilots routinely operating in this area of the flight envelope. To accomplish this, the FAA teamed up with the International Aerobatic Club and the National Association of Flight Instructors, both subsidiaries of the Experimental Aircraft Association, to discuss their views on accident scenarios that have plagued general and military aviation since the earliest days of powered flight.
Nothing has a potential of changing people's lives more than aviation. It changed entire cultures because suddenly the boundaries that we had were no longer the boundaries.
Aviation comes with some risk, and if you are going to be a part of the aviation industry, you must understand that risk and you must mitigate that risk as much as possible. Otherwise, your industry is not going to grow.
Safety has to begin with an industry that is dedicated to safety. And the FAA's job is to oversight their compliance with safety.
If you can find the system, find the threads, and then foster collaboration on safety in particular, I think that's where the breakthroughs are going to come.
We're committed to it, and when FAA and the industry are committed to things, we have accomplished tremendous results.
The Federal Aviation Administration has been faced with challenges and goals since Congress created it back in 1958. The Act, which was passed by Congress and signed into law in the wake of a tragic mid-air collision over the Grand Canyon, replaced the old Civil Aeronautics Administration with a modern agency. The Federal Aviation Act that was signed into law that year required all U.S. airlines and U.S. airplane operators to maintain the highest practical level of safety in the public interest. The new FAA was directed to establish and maintain a comprehensive set of up-to-date aviation regulations. It was also given sole responsibility for the nation's system of air navigation and air traffic control. But one of the agency's biggest roles has been that of promoting and enforcing aviation safety. It's there that the FAA has truly made its mark. Aviation accident rates have declined year after year. As a matter of fact, in 1998, not one single U.S. airline had a serious accident, nor was anyone killed while traveling aboard a scheduled U.S. air carrier. That remarkable statistic remains the exception, however. And although air travel is far and away the safest form of transportation on Earth, airline accidents still occur. When they do, they grab headlines everywhere. An amateur video camcorder taped this horrifying image of an airline crash in Sioux City, Iowa in 1989. A DC-10 jumbo jet with 296 people on board
was severely disabled when one of its engines malfunctioned and exploded. In a 1-billion-to-1 shot, all the jet's flight controls were disabled, even backup systems, leaving the pilots with nothing except thrust, the power of the jet engines. Because the flight crew was highly skilled, they managed to get Flight 232 to an airport where emergency equipment was standing by. But in the daring attempt to land it, the big jet caught fire and tumbled. Miraculously, 184 of those on board were saved. Today, Flight 232's captain, Al Haines, has retired from airline flying, but maintains a grueling schedule as a public speaker. He travels to over 100 cities every year to address safety forums.
I think there are 5 factors that led to the degree of success we had that day in Sioux City. Those 5 are luck.
Haines attributes the degree of survival on Flight 232 to both improvements in flight crew training and better emergency preparedness on the ground.
The training that we had on United, they have gone to what they call a command leadership resource or cockpit resource management, depending on how you want to call it, where it's a team effort. So the crew all works together as a team. Use whatever things you have available. The people on the ground have all been trained the same way. So all these trainings were reinforced that this is the way that we should be trained. So all the airlines now use a crew resource, CRM or CLR procedure now, which they didn't do before. Because you have, the captain is no longer, he's the office manager. He's got the final say. But let's use the experience you have in the other 2 seats. Prior to this, in the 50s, the other 2 seats didn't matter. It was the captain who made all the decisions.
In its quest to keep today's U.S. air transportation industry the safest in the world, the FAA relies on the Flight Standards Service, its frontline force, to interact with air crews, ground crews, and operators.
Hello there. You guys flying 1641? We are, Captain Hawk. Jim Gardner, nice to meet you. How you doing? Scott Taylor. Hey, Scott, how are you? Show you my 110A. I was hoping to do a cockpit inspection.
Flight Standards consists of a cadre of more than 3,000 dedicated professionals, including inspectors like Jim Gardner. They stage out of more than 100 district offices across the country and overseas, and deal directly with airway users. Today, Gardner will accompany an air crew on a flight from Washington to Denver to measure its level of professionalism. Meanwhile, Inspector Bill Moss evaluates a private pilot for his knowledge of FAA regulations, as well as his flying skills. Moss, who was once a combat helicopter pilot in Vietnam, is now dedicated to making the skies as safe as possible for those who choose to venture there.
How you doing, sir? Bill Bergman with the FAA.
Flight Standards Inspector Bill Bergman, who's also a flight engineer in the Air Force Reserve, concentrates on the complex issues of aviation maintenance. Bergman inspects aircraft of all shapes and sizes, from big jets to helicopters, to help make sure they are safe to operate. Inspector Mona Tyndall, whose specialty is aircraft radios and avionics, may also be called upon to spot check aircraft operators, like Ron Gatewood. Tyndall's job on this particular day is to make sure that Gatewood's airworthiness inspections, licenses, and certificates are all up to date. All inspectors share in this responsibility. Like most operators, Gatewood passed this check with flying colors. The Flight Standards Service also provides an ongoing series of aviation safety programs throughout the U.S., including regular seminars to help encourage safety and proficiency.
Instrument conditions is the leading cause of general aviation accidents.
The FAA knows that those who regularly attend these seminars have better than average safety records and awards those who achieve safety-related goals. Flight Standards inspectors even regulate and monitor air shows to keep them safe for the general public. Air shows are one of the most popular outdoor events in America. They help inspire young people to seek out careers in aviation. And, although exhibition flying is risky by nature, the FAA wants to be certain this form of entertainment remains as safe as possible. The work of the men and women of the Flight Standards Service is both challenging and diverse. Flight Standards inspectors are typically seasoned professionals with years of experience in aviation. After all, this frontline team must interact day in and day out with those in the aviation industry. they also represent the nearly 50,000 employees who make up the FAA. In the very early days of airline operations, on-time arrivals like this one were few and far between.
From New York and the East, arriving 4:20 on time.
There was very little regulation and no flight standard service. When this tri-motor Ford was the airliner of choice, flying was barely 30 years old, and passengers brave enough to go by plane were happy to arrive on the day they were supposed to, let alone the hour. In the years after World War II, when both the airlines and private flying were really coming into their own, the skies overhead were still not as regulated nor as safe as they are today. Al Haynes joined United Airlines in the 1950s. He says that back then it was impossible for air traffic controllers to keep an eye on everything.
Back in the 50s, first of all, not all the areas had air traffic control radar. So sometimes some pilots would kind of cheat a little bit. To save time, they may go from point A to point C and just kind of report passing by point B and say they were there. It didn't happen very often. It only happened when the weather was good. You never really went plowing through the sky without knowing where you're going. As it began to progress and we got bigger and faster and all this, the crew began to become more involved until today we have cockpit resource management, or as United calls it, command leadership resource training, so that the crew works together.
Haynes says the advanced weather radar now available has made another big difference.
Weather was always a problem when you were flying aircraft with no weather radar because you had no idea what you're going into. So you would usually go around it. So delays were very common in the summer because of skirting thunderstorms and so forth. Now, with your radar and their radar, you can pick a hole and go through it and usually not have any problems. So that's another big change that's taken place, much for the better.
Al Haynes knows, better than most, just how critical a good aircrew can be. Every pilot knows that you can't fly an airplane without controls. Haynes and his team pulled off a miracle.
Oh, boy.
In recognition, he has received dozens of awards and honors.
I guarantee we will. Thank you. That's very nice.
Associate FAA Administrator Tom McSweeney has watched the Flight Standard Service mature. McSweeney began his career in aviation as a structural dynamics engineer, then came to work for the agency in the mid-1970s. Like Al Haynes, Tom McSweeney has seen a lot of change.
And if you look over the last 10 years, there's a lot of programs that have come on in AVR and in flight standards specifically that have been directed toward actually reducing the number of lives that are lost in aviation accidents. The training programs, the air carrier training programs to get the pilots to talk to each other, to get the pilots to have better communication in the cockpit. Those are very important. We are already seeing benefits of those. Technology, of course, has moved in massive amounts into aviation, clear down to general aviation. So there's been a lot of improvements, but I think I measure the success of what we do by what happens to the accident rate.
McSweeney says that although the accident rate has been going down, the increasing popularity of jet travel is putting greater demands on the FAA to root out all the causes for airplane mishaps and eliminate as many as humanly possible.
We still have to make a great big improvement because, especially in air carrier operations, they're moving up so fast that if we don't reduce the accident rate over the next 10 years very dramatically, and we say 5-fold reduction, that the accident rate or the number of accidents per whatever time frame you want to have are actually going to rise. And we believe that that's just an unacceptable thing.
The result is an ambitious new program called Safer Skies, which will require a lot of assistance from flight standards. McSweeney explains that the Safer Skies agenda is a whole new way of thinking about safety.
How do we actually get to a 5-fold reduction? It's a question that I asked about 1.5 years ago. I said, well, we've been talking about this 5-fold reduction, but where's our line in the sand? Where's our mark on the bark where we say, this is what we're going to do, and we know that it's going to give us a 5-fold reduction? And the Safer Skies agenda is the way of doing that. It's a whole new way of thinking about safety. And the key here is to take the data and find out where we should focus our resources to have the biggest bang for the buck. What we historically have done in the FAA is be driven by a lot of different influences. People want this, and another constituency wants something else. And that leads us to doing a lot of things, but is the payoff of those things worth the resources we spend on them, or could we actually save more lives if we funneled those resources to different programs? So taking the data, you identify your highest risk categories, and then you do an analysis of probable causes of all of those accidents, and you drill down and you keep asking questions, why? And you get to what we call root causes.
Peggy Gilligan is Tom McSweeney's deputy. The two were part of the team that spent 2 years just laying out the data collection and analysis profiles for Safer Skies. The job now is to sift through the arriving data to search for ways to fine-tune safety.
Now the hard work begins. The analysis, understanding what happens in an accident scenario, looking at similar accidents to see what's happening across the board that's similar. Why are pilots doing what they're doing? Why does the aircraft do what it does? What happened at the airport environment? So that we can determine where we put our efforts to make corrections. Is it pilot training? Is it a change to the aircraft? Is it air traffic control procedures that might need to be changed so that we can change the environment so that that set of circumstances don't occur again? That's the hard part.
Gilligan says the search for root causes is vital and very dependent upon data collection by flight standards.
It takes longer than any of us would like, but we're trying to give it the right time, the right amount of time, so that we're sure we get the right output at the end.
The ultimate success of the Safer Skies agenda will depend on newfound cooperation between the FAA and the aviation industry.
I have to say it's actually been a pleasure and a joy to put together this agenda, because we really got a lot of energy around working together to solve the real problems. We've broken the agenda into several sections, one where we're focusing on commercial aviation, because while the issues are very similar, the solutions are different. The regulatory relationship FAA has is different between the commercial segment and the general aviation segment. And then we have a special focus on cabin safety because we think there are real areas of improvement there in terms of passenger injuries and passenger responsibility. What we've learned is it's not just the operator or the crew member that has safety responsibility. Passengers have a responsibility to understand what they can do to enhance their own safety, and we're trying a real focused education for them in that element of the agenda. But looking at the commercial aviation agenda and the general aviation agenda, we met with groups of industry representatives, and in both cases they embraced the idea of working together to enhance safety. They accepted as part of their responsibility the need to reduce the fatal accident rates, and that was very encouraging for people, all of us, to realize it isn't a government responsibility, it's not an industry responsibility, but it's a shared responsibility.
Pat Andrews, a leader in corporate aviation safety, agrees that the need for collaboration is vital.
Just like my business is diverse, the entire industry is diverse. Everybody has a certain part of the business that they're pursuing. Maintenance operations, flight operations are very different. Air traffic has its own set of issues. But until you can take all of those players and find their common threads, what binds this industry together? This is a system. It's not just a collection of independent players.
Like Al Haynes, Pat Andrews is a fellow recipient of the coveted Presidential Citation from the Flight Safety Foundation. Andrews manages a worldwide corporate jet operation and is responsible for a large fleet of executive aircraft and hundreds of personnel spread across the globe. Andrews accumulated thousands of hours as a corporate pilot before assuming her role in management. She, like most of those who earn their living in aviation, loves to fly and, when time permits, slips away with her family for brief side trips in her husband's single-engine plane. Those trips are few and far between, however, because when she isn't looking after her corporate responsibilities, she's working on safety issues. Andrew says one critical key to gathering the data needed for the success of the Safer Skies agenda is the need for more trust between airway users and the agency.
The challenges are huge, there's no question, but the FAA, I think, is beginning to understand the importance of trust. And especially if you're talking about general aviation, there's a lot of work to be done there. Taking a position of being, seeing the operators in the system as customers is an important first step. It's not unlike someone in my job, a manager, saying my employees are my customers, and they really are. Because at the end of the day, what I want them to do is I want them to come in, bring all their energy there, and then make good decisions about the work that they do every day without looking over their shoulder, without wondering, what am I thinking about the job that they're doing? They have to know that they've got my backing and that I'm supporting them in what they're doing every day. That allows them to focus on the decisions that they make.
Good decisions in aviation are vital, especially at 30,000 feet. One of Jim Gardner's duties as a flight standards inspector is observing pilots in the safety of a high-tech flight simulator as he puts them through the rigors of realistic in-flight emergencies. It's all part of risk management, of keeping the ball in your court. In the simulator, Jim can create any one of dozens of critical problems for pilots. He can suddenly make an engine fail on takeoff and watches to see that the aircrew works together as a team, identifying and shutting down the correct engine, controlling the plane, and landing the aircraft smoothly and efficiently. A sudden decompression at altitude can be a more serious problem. The airplane must be controlled, oxygen masks must be donned, and a rapid descent to a safe, lower altitude must be made as quickly as possible.
Okay, you're cleared to 10,000 feet. Why don't you turn left to 330 heading? 10,000 feet.
Such emergencies have extremely minute probabilities of ever happening, but when one occurs, it is vital that every member of every aircrew be prepared to react quickly and correctly to prevent things from getting out of hand. It's all part of a team effort to make sure that aviation safety works. When an accident does happen, the FAA and the National Transportation Safety Board immediately set out to find the cause.
Impacted here, and that's what I was talking about, slid for 20 feet.
In the past, a frequent explanation for accidents has been pilot error. And in some cases, pilots have made fatal mistakes. But in many of the more controversial accidents, experts now believe that making the pilot a scapegoat kept investigators from digging further. As a result, pilots have been reluctant to admit having made mistakes in the cockpit for fear they will be accused of malpractice. But under the Safer Skies agenda, they are being urged to come forward and report their mistakes. It's something no pilot feels comfortable about doing.
There's no question that pilot error is a very important, is a big part of a lot of accidents. Drivers make mistakes, they run stop signs, they do this sort of thing. Pilot makes a mistake. Unfortunately, when a pilot makes a mistake, an awful lot of people can suffer. If a doctor makes a mistake, he may lose one patient. If a pilot makes a mistake, he may lose 300 passengers. But the thing that irritates me most about pilot error is they will report an accident is pilot error, but they won't say why the pilot erred. Why did he err? Was he not properly trained? Did he not get the full understanding of this equipment? These technicians design this equipment and it is extremely complicated. And sometimes we don't get maybe the full training we should have to get it done. And now they find out, well, we got to tell them a little more about the system or go a little deeper into the system or something like that. Or maybe we've gone too deep and they're confused by what all the information is available to them.
One of the things that I actually detest, and I'll use that word, is the word, well, actually it's two words, it's pilot error. You know, I don't think a pilot sitting in an airplane making an error is doing it consciously or purposefully. I don't believe that pilots are the only ones that make errors. I like to look at it, again, you'll see that I like to think system-wise. I look at the airplane as a system, and look at the cockpit as a system. Let's say a pilot made an inappropriate maneuver based upon the conditions. Banked left instead of right, shut off the wrong engine. You know, what we would call the wrong engine. Well, You got to look at the whole system in the cockpit. You have to look at the decision making of the pilot. You have to look at how data was presented to the pilot, how information came into the eyeballs to tell that pilot to do something. You have to look at the training. You have to look at all kinds of things that could have impacted that decision. Yes, you can look at flight and duty time, and that's an important thing too. You know, was the pilot tired? But I think you have to look at the whole system. I think when people talk about pilot error, it kind of prejudices the situation, and you stop really getting data because people start pigeonholing things.
There are lots of things that have occurred before we get to that last step that we believe we can intervene earlier, and the pilot is never put in that position. The pilot never has to make that last-minute judgment under that stress where the possibility of making an error is really very high. And that's really what we're looking for. How early in the causal chain can we identify a corrective action that never lets the pilot get into that position?
Nick Lacey, the director of the Flight Standards Service, says that to encourage the gathering of vital data for the Safer Skies agenda, the FAA has created a kind of amnesty program for pilots.
And I think the operative word is trust. And I think, you know, I mean, we're starting down that path. And I think it is a cultural change to recognize when an inadvertent error is made versus a willful, overlooking of a regulation, that there is a difference. And we are interested in the safety arena at getting at that mistake that is made, whether it be a mechanic or pilot or anyone, a weatherman, anyone associated with the entire safety system out there.
Lacey and his deputy, Ava Mims, are responsible for implementation of major portions of Safer Skies.
We don't really care, you know, who's causing the error. We care about how can we prevent it, how can that education get out there in a non-threatening kind of a way. Otherwise, we will never get the data. If there's a inkling that, you know, this is going to be used against me, and it was inadvertent, then why should I report it to you? So, I mean, we're working on issues like that to, you know, be able to have as much information as we can to feed back into a safe system.
And the data flow, it's been in place for a little over a year, is just marvelous. Mm-hmm. And it really is the future at getting to the next level of reduction in incidents and accidents. So it's exciting. It's really exciting to be here.
Although much of the focus of Safer Skies is on the airline industry, there's also a good deal of attention being paid to general aviation. General aviation is an industry term that refers to almost all air operations aside from the scheduled airlines and the military. The United States has more general aviation aircraft than any other nation on Earth. But the general aviation accident rate is higher than it should be, and that concerns the entire aviation community, including the FAA. But there is optimism here as well.
We see real growth in the general aviation community, a real commitment to enhancing the level of safety. We see a real concern about the level of accidents that the general aviation community continues to experience. And we've announced a whole focus area just focusing on general aviation, working in partnership with the General Aviation Coalition, which is a group of about 17 general aviation organizations that have come together to help us set the safety agenda to reduce fatal accidents in general aviation.
Ron Gatewood is one of hundreds of general aviation operators across the country. A former Marine flyer, Gatewood now runs a flying school and charter business. He speaks for many operators when he says that a better relationship with the FAA is hinged to a better overall safety record.
I think one of the strongest things that we could do is develop a better relationship with the FAA, one in which we are treated as a client. We have a business to run, we have a profit to make, we want to be safe, and being a client with the FAA and a partner with the FAA, as opposed to having an adversarial relationship, which is what I've seen in the past. I think that would do more to contribute to a better safety record than anything that we could do.
There are some issues we disagree on, but it is not an adversarial disagreement, it is a professional disagreement, and we work to find the right solutions. And it is only because of that partnership that I think we've seen the improvements in safety that we've gotten in the last few years.
Yeah, I agree that with education and training, that that would go a long way in helping the general aviation industry realize a safer environment. I mean, when I think about aviation, I think about the folks that are Oshkosh and Sun and Fun. That, I mean, it's in their heart and it's in their blood. I mean, they are out there having fun doing what they're doing, and I think it's incumbent upon us to make sure that it remains fun. And if it's things such as the production of our seminar in the box that our safety program managers have worked in partnership with industry. If it's my good buddy Bill O'Brien, I think you probably know, who writes a lot of articles on general aviation safety. He's our national resource specialist for safety, along with Roger Baker. The passion of those types of individuals to ensure that the industry, that particular part of the industry, is still having fun. That's aviation in general, no pun intended. So, with the proper training, with delegation of a lot of the things that we in the past have termed inherently governmental kinds of things, the industry associations can do that a heck of a lot better than us. They're out there every day, and I think if we pass on those types of roles and responsibilities and awareness, that we're going to help that industry be as successful as they have been, but more importantly, continue to have the fun that we've all enjoyed having at air shows and fly-ins and that kind of thing, which is, aviation in general.
Aviation in general, that's the FAA. And it's the men and women of the Flight Standards Service who interact with everyone who builds, instructs, flies, and operates the diverse American fleet. It all goes back to that Federal Aviation Act that was signed into law in 1958.
First of all, it says that the air carriers, and you can lump the manufacturers in that, are required to operate to the highest practical level of safety in the public interest. That's an important statement. It also talks about the FAA's role. And it says the FAA's role is one of promoting aviation safety. But it really places the burden of aviation safety on the industry.
I really do believe that safety is primarily driven by the quality of the decision-making of the participants in the industry. And I don't care what they're doing, whether they're maintaining aircraft, whether they're flying aircraft, directing aircraft, or making regulations. If they have good decision-making processes in place, by and large, we're going to get to a much better place.
My wife says to me sometimes, how can you get out of bed in the morning and be so happy? Because I get out about 4:45, and by 5:30 I'm whistling, and I'm ready to go off and go to work. I leave about 6:15. And I said, well, that's the difference between having a career and having a job. If it was a job, I wouldn't, I'd drag myself to work, but as a career, I really enjoy it.
Over the past few decades, the helicopter aeromedical industry has proven itself to be a very effective means of saving the lives of those who are critically ill or injured. However, during the relatively short life of our industry, far too many aeromedical programs, its crews, and sometimes its patients have fallen to tragic accidents. And the highest percentage of these crashes have been caused by human error. Now, often this fact leads us to ask the question, what was the pilot thinking? Why did he act the way he did? And what's even more confusing is why are the same mistakes still being made over and over again throughout our industry? As you go through this training and watch the scenarios, we suggest that you heavily concentrate on the error chain depicted in each scenario and how these steps ultimately lead to a crash. Ask yourself, what were the contributing factors? Were there opportunities to break this chain? Was there a specific culture and a program that affected the pilot's decision-making? And finally, were there direct and/or indirect pressures that influenced the pilot's decision? And finally, before we begin with the scenarios, there are two major points to note. First, none of these scenarios are contrived. Each contain multiple contributing factors and influences taken directly from industry accident and incident reports, as well as confidential surveys recently completed by your peers concerning practices and safety problems within our industry. And second, this video would not be possible if it were not for the support of aeromedical helicopter operators, hospital programs, and their crews, as well as all of the other supporting agencies named in the closing credits of this video. These companies donated their equipment, personnel, and the display of their logos to demonstrate unsafe safety practices in the sincere hope that taking a proactive approach through this training will help to significantly improve the safety record of this worthwhile industry. Now let's begin with the first scenario. The day begins with Ann, an experienced flight nurse, in her home about to leave for a day shift. As she leaves, she promises her daughter that she will be home that evening to see her dance in a recital. The morning also starts with Skip, the day shift duty pilot, on the phone with his ex-wife. He is promising her that he will be there at 8 p.m. sharp to pick up the kids for their planned week-long camping trip. Skip's ex-wife reminds him that she too has an obligation that evening and would not appreciate him being late. The shift begins with Skip checking weather, which in the morning is VFR with haze, but is forecasted to diminish to IFR conditions by the end of the shift. This is a VFR program based at an airport. Following his weather check, Skip pre-flights the aircraft, while Ann checks all of the medical supplies and equipment on the aircraft along with Paul, a new flight medic who has just completed training during the past 2 weeks. Following the pre-flight activities, Skip, Ann, and Paul join a program staff meeting where the prior month's activity was reviewed. Flights are down, another flight program in the local area is turning up their marketing efforts, and the hospital administration is getting concerned. The day progresses with no flight requests. Skip keeps himself busy reading magazines while Ann and Paul inspect and clean their equipment. The weather has started to deteriorate, and the new forecast continues to support IFR conditions before the end of the shift. By mid-afternoon, the weather has lowered, with rain showers and mist also added to the amended forecast. Skip feels comfortable to call his ex-wife at 4 p.m. to tell her that the weather has lowered to the point that he doesn't expect to fly and sees no problem with him being on time for the kids. Shortly after that call, a flight request comes in for the transfer of the patient from the requesting hospital to a third hospital. Skip checks the weather, and all points are still reporting basic VFR conditions, even though the forecast is for IFR. Skip is a locally familiar pilot who has flown this route many times before, and although the weather has diminished throughout the day, it's still above the minimums for their operation specifications. He's also concerned about their low flight activity and decides that he can fly the trip and be back in time to beat the IFR weather and pick up his kids on time. Ann questions his decision because of the weather and her concern for getting back to make her daughter's recital. Skip assures her he would not accept the flight if he didn't think he could make it all the way home. Paul, the new crew member, offers no opinion on the decision to fly. The helicopter departs the airport for the requesting hospital. The weather during the first leg is as stated in the weather briefing, and they arrive at the referring hospital without difficulty. The patient is loaded into the helicopter and they depart for the receiving hospital. During this leg, the weather has obviously started to deteriorate due to ceilings, haze, and mist. This causes Skip to have increasing concern as to whether the conditions he's observing will worsen before they get home. In addition to attending to her patient, Ann is also becoming concerned about the weather and its possible effect on getting home. The helicopter arrives at the receiving hospital and the patient is unloaded. While the medical crew is delivering the patient to the appropriate location, Skip receives a telephone weather briefing which reveals marginal VFR to spotty IFR conditions in the area and below Skip's personal comfort level. When the crew returns, he briefs them on the current conditions, his concerns, and suggests calling the hospital van to come and get them and leaving the helicopter overnight. Anne immediately becomes very upset and ridicules Skip for his decision to take the flight in the first place, especially when she questioned the weather from the start and reminds him of her promise to her daughter. She argues that if the weather is at legal operations minimums, and he has flown that route many times before, he should at least try it before he gives up. His thoughts also briefly go to the grief he will receive from his ex-wife for being late to get the kids. He looks to Paul for his thoughts, and he simply says he's willing to go along with whatever the other two decide. Rather than continue the argument, Skip agrees to try it, and they depart for the base. This hospital-based program has been in continuous service for 15 years and using the same vendor for the past 10 years. Even though both the hospital and the vendor were well respected in their service area for professionalism and response time, the hospital was on a new campaign to bolster its image, and the vendor was doing the same in preparation for contract renewal negotiations about to begin. One area of major concern to the hospital was the drop in the number of scene requests the program received. Recent staff meetings had focused on this concern and ways to improve the scene call numbers. Numerous in-service training and PR flights have been conducted to bolster the use of air care for scene calls, as well as provide additional training for first responders, and it worked. On a beautiful VFR day, the dispatch center received a call from a nearby county for air care to respond to a single-car accident involving a mother and her son. The duty pilot was an experienced aeromedical pilot, but relatively new to this program, and was delighted that a flight request for a scene run had finally come in. Upon departure, the pilot entered the coordinates that the first responder unit called into the air care dispatch. What the dispatch center and the pilot did not know is that the first responder called in incorrect coordinates, which would send the helicopter to a point in the county 15 miles away from the actual scene. When the pilot arrived at the point given, there was no sign of any accident or landing zone. Still new to the area, descriptions of highway numbers and intersections at the actual scene did not help. However, the medical crew was familiar with some of the landmarks they were over, and the pilot relayed this information to the local first responder. Additionally, the first responder's explanation of where they were allowed the air care dispatcher to look up the location on their county grid maps and plot their own lat-longs to give to the pilot. The error was finally cleared up, and the helicopter proceeded to the actual scene location with an ETA of about 12 minutes later than planned. Because the mother was already removed from the vehicle and the helicopter had not arrived, EMS elected to send her by ambulance to a local hospital for initial evaluation. The landing zone was a field next to the road, and EMS and fire crews blocked the road from all traffic for the helicopter. The pilot landed the helicopter so as to position the loading side toward the accident, which also kept the tail rotor out of the direct path of the cruise. However, this put the tail into the wind. Since rescue crews were still working on extricating the child from the vehicle, the pilot elected to shut down the helicopter during the wait. Approximately 5 minutes later, the child was freed from the vehicle and loaded into the helicopter. It was obvious to the pilot that this child was in very bad condition and needed to get to the trauma center as quickly as possible. Once the area was clear of ground personnel, the pilot started the helicopter's #1 engine. During the process, a hot start occurred. The pilot glanced back at the medical crew to see them frantically working on this critically injured child. They had no clue that the hot start even occurred or that a problem might exist. The pilot tried the second engine, which started normally, followed by an acceptable restart of the first engine. He still had no idea if any damage had occurred and considered aborting the mission. However, with a blocked roadway, a critically injured child, and engines that seemed to be running fine, the pilot ultimately elected to depart for the trauma center. Tim is an experienced aeromedical pilot. His VFR program works him on a 7-on, 7-off schedule, alternating each tour with days or nights. He was currently on his 6th night of a 7-night tour. This was a particularly long week with no flying due to lack of requests or marginal weather forcing the flights to be turned down. This didn't bother Tim too much since he wasn't in the flying mood. However, the lack of activity was taking its toll on the medical crew. By this point in the tour of nights, they were bored, restless, and tired of having to do make-work projects. In spite of the inactivity, Tim still didn't get much sleep during his nights on duty. He was concerned about his financial situation, which was strained due to a new home he and his wife were having constructed. In an attempt to alleviate some of his money concerns, he was working a second job during his off weeks and when he was on nights. Most of the work was for a friend of his who owned a fly fishing retail store. Tim was making good use of his outdoor skills and knowledge in retail sales by performing many functions at the store. He had worked there on this day up until it was time to leave to report for his duty shift at the hospital. The call came in at dusk for an inter-hospital transfer back to Tim's program base. The weather check revealed that the conditions were at best marginal VFR, with scattered rain showers and thunderstorms in the forecast. The weather was legal, but questionable. Additionally, the weather information at the location of the referring hospital was minimal. The doctor at the referring hospital was becoming concerned as to why it was taking so long for the helicopter service to decide whether they would be coming for the patient. He was a privately rated pilot and decided that the conditions were acceptable and phoned the helicopter pilot directly to advise him of this, and that this patient was in serious need of services they could not provide. Tim briefed the medical crew, and they suggested just having a look and turning back if it wasn't good. Tim decided to give it a try, and the helicopter and crew departed for the referring hospital. The weather didn't change, but it was not good. The workload was high, and Tim was continuously deviating around the rain showers. Upon arrival at the referring hospital, the weather was a little worse, but he found the hospital pad and landed without incident. While the medical crew was packaging the patient, Tim became increasingly concerned about the weather. When the medical crew came out with the patient, it was obvious to Tim that they were going to have their hands full. The referring hospital had waited until the very last minute before they called for more advanced help. Additionally, Tim realized that the patient was a very close friend of his. They loaded the patient, and Tim started the helicopter and departed. The workload remained high, and more deviations were required. The medical crew were oblivious to the conditions. Their hands were too full with the patient, whose condition was worsening. Now Tim has a new concern: fuel. All the deviating has taken its share of his normal fuel, and he is unsure of his ability to safely make it back to his hospital without seriously compromising his fuel reserves, and there were no airports along the way to obtain fuel. Uncomfortable with the fact that he might land back at his hospital with only 10 to 15 minutes of fuel remaining, he is considering diverting to a nearby community hospital with a helipad. This would require the patient to have to complete the trip by ground. However, he was also concerned about the criticality of this patient and the urgent need to get to his hospital. Tim elected to continue on to the medical center. Bobby is a pilot who was recently assigned to a contract that was nearly 20 years old. From the very start, Ken, the long-tenured lead pilot at the base, took on the role as mentor to Bobby. At first, Bobby was happy with this because the feedback from the vendor on Ken was very good. It was also immediately obvious to Bobby that Ken appeared to be the favored pilot of the medical crew. It was also obvious to Bobby that things were done differently at this base compared to his prior assignment. For example, pilots were required to complete a computer form every time they turned down a flight for weather, stating the exact reason and include a copy of the computer-generated weather reports with the form. Ken made a practice of closely reviewing all of the turned-down flight summaries in the computer with the other pilots and sometimes questioned the no-go decisions. He also noticed that the hospital administration required the dispatch center to keep exacting records on each flight, when the call came in, and how long it took for the pilot to start and take off from the time the flight request came in. Additionally, the medical crews were almost all longtime team members and exhibited signs of impatience during Bobby's aircraft starting and pre-takeoff procedures. But what bothered Bobby the most was that during his first month at the base, some of his observations of Ken's actions on shift change were not consistent with the company's safety practices. Ken's pre-flight was minimal. He never observed him draining the sumps, closely inspecting the aircraft, or reviewing the maintenance status reports on the helicopter. He never requested any pass-down information on shift change. Getting into the cockpit after Ken, Bobby would notice that the checklist was almost always misplaced and switches would often be in the incorrect position versus where they should be after shutdown. Recently, one of the newer medical crew members, Dave, who felt comfortable talking to Bobby, expressed that he was uneasy at times when flying with Ken. He explained that Ken seemed to accept flights under worse weather conditions than the other pilots would accept. Also, Ken often likes to fly much lower than the other pilots and seems to not mind going into much more hazardous landing zones for scene work. Finally, there was the time a couple of weeks ago when Ken took another med crew member for a low-level military-style ride in the company's Spare while returning from the maintenance base. This crew member bragged how he got to sit up front while Ken flew low over a field, crow-hopped over trees, flew down a road at treetop level, and did extremely steep bank turns. Dave added that he wanted no part of this type of activity, but was afraid to say anything because he was so new to the program and that the crew member, named John, enjoyed it so much. Not long after this conversation, a flight request came in for a 3-point transfer, and during the deadhead leg home back to the base after the patient was dropped, John tells Bobby that he should do a low-level run to initiate Dave, which hadn't been done yet, and give him a thrill, just like Ken does for all of the new med crew members. Bobby, trying to act like a part of the team he just joined, dropped down lower, but still within company and FAA guidelines. Although Dave had indicated that this was low enough for him, John pushed the issue and challenged Bobby to be as good of a pilot as his boss Ken.
For over 50 years, the commercial helicopter industry has proven itself to be a very effective means for serving individuals, companies, and communities. The services provided by these helicopters are as far-reaching and diversified as the helicopter is versatile. However, an unacceptable number of these helicopters, their pilots, and passengers have succumbed to senseless and often tragic crashes. And the highest percentage of these crashes have been caused by human error, namely pilots making poor safety of flight decisions. What's even more alarming is that the same mistakes are being made over and over again throughout our industry. As you go through this training and watch the scenarios, we suggest that you should concentrate heavily on the error chain depicted in each scenario and how these steps ultimately lead to a crash. Ask yourself, what were the contributing factors? Were there opportunities to break the chain? Was there a specific culture within the company that influenced the pilot's decision-making? And were there direct and/or indirect pressures affecting the decisions of the pilot? Finally, before we begin with the scenarios, it is important to emphasize that this video would not have been possible if it were not for the support of the helicopter operators shown in the scenarios and named in the closing credits. These companies allowed the use of their equipment and personnel and the display of their logos for the demonstration of unsafe practices in the sincere hope that taking a proactive approach through this training will help to significantly improve the safety record of our industry. Business was good for this 2-year-old helicopter company. They had made a positive name for themselves, providing sightseeing, photography, and charter service in this large city market. Additionally, they recently signed their first major electronic news gathering contract for one of the major networks. The bidding competition was fierce, the budget was tight, and the contract was short-term, with a long-term renewal option based on satisfactory performance. Paul has been a pilot for this operation since its founding and one of the 3 full-time pilots employed here. He has a good safety and work history and enjoys his job. But it hasn't been all easy. The news contract has added a much higher workload to the pilots because of the 24-hour service required. Also, the customers often showed a lack of understanding about safety of flight issues, especially regarding weather. One of the 3 pilots had been out sick with the flu, leaving Paul and the other pilots to carry the load with no breaks. The network doesn't care about the operator problems. They just want their aerial video. The 24-hour, 7-day-a-week demands of a news contract also added a new workload for the maintenance department, as the entire company tried to deal with making it through the trial contract period and ultimately winning that long-term contract. This day started like most others. Maintenance was checking the helicopter and finally dealing with some small squawks because the helicopter flew most of the night on a big story about a large protest demonstration that went out of control. Paul checked the forecast for his day shift to determine how the weather might affect his entire day. Often when the call comes in for a hot story, there's no time to receive an update, especially when you know your competition will be racing you to be first on the scene. Maintenance released the helicopter, but reminded Paul that a replacement fuel quantity sending unit for the one that was acting up the previous night had been ordered, and to watch his fuel consumption carefully. Paul pre-flighted his aircraft and began his flying day with the morning traffic watch flight and covering 2 associated auto accidents. Paul and his camera operator noticed the fuel gauge problem, but they would handle it with more frequent fuel stops. Shortly after the traffic watch duty and a quick refueling, Paul and his crew were back out covering a train derailment and a van fire. When Paul finally had a break in the action, he was immediately recruited to give a safety and security briefing to some local fire department trainees. It wasn't long before Paul and the crew were back out to cover a structure fire and then happened to be on scene for a car chase that ensued. Soon the chase concluded, and as the helicopter was returning to base, they were dispatched to a rescue operation where 3 fishermen were trapped on a jetty due to the rising tide. Paul wanted a quick fuel stop because he wasn't sure about his exact fuel consumed, but the competition was already on the way, and the network on Paul's contract wanted to break into live coverage and told him to get there immediately and preferably first. Paul did arrive first, just in time to transmit video of the first fisherman being lifted into the rescue helicopter. The competitor arrived a couple of minutes later, and they both covered the rescue of the second fisherman. By this time, Paul was really uncertain of how much fuel he had left due to the bad gauge and told his producer that he wanted to return. She became emphatic about him staying on the scene as long as the competition was there and the 3rd victim was rescued. Since the rescue was progressing quickly, Paul decided to stay on scene. The 3rd victim was removed from the jetty. This prominent helicopter flight training company has been very busy lately. The need for qualified pilots has been at an all-time high, and the time has never been better for career pilot hopefuls. School enrollment has been nearly to capacity, and the students and instructors have never been more enthused about their prospects for finding work as a career helicopter pilot. One of the company flight instructors, Manny, who has about 1,250 hours total time, is now very pleased at how employable he is in the mainstream of the industry. Because of this, he was preoccupied with faxing off resumes, making phone calls, and performing other activities associated with moving on from the world of flight instruction. With over 1,000 hours of instruction behind him, he is extremely comfortable in the aircraft and has developed a feeling that he can recover from any situation a student might put him in. Manny also has been telling his students that pre-lesson and post-lesson briefings are really not necessary, and he'll just talk about their lesson plan in the air, in spite of the fact that the other company instructors are all conducting formal lesson briefings with their students. On this day, the student had already been waiting for 15 to 20 minutes for Manny to first get off the phone and then to finish telling his buddies about his conversation with a potential employer. A company supervisor reminds Manny that he and his student are now running well behind schedule, and if they are going to get the lesson done prior to the next time slot, they need to get going. Manny tells the student to shorten the pre-flight since the aircraft had just been flown and hurry and get the helicopter started. The student did as he was told, performed a quick cursory pre-flight, and then immediately began the starting process. After another quick phone call, Manny arrived at the helicopter and climbed in as the student was still working through the checklist. Manny, who was unhappy with the slow progress being made, takes the checklist from the student and puts it away, saying there's no time for that now. Manny skips the run-up checks and takes the controls himself for the departure. As he does so, he's still finishing his can of soda, which he holds between thumb and forefinger, while he holds the cyclic with his other 3 fingers. The pickup was abrupt and hurried from the parking area, and the actual airport departure consisted of a rapid 360-degree turn followed by a very exaggerated nose-over takeoff. The aggressive takeoff caught the attention of other instructors and their students who were standing on the ramp. They were all commenting and shaking their heads in disapproval of this cowboy style of flying. Once in the practice area, Manny conducts a reasonably professional lesson for the first 20 to 30 minutes, concentrating on hover work. But then he starts to get a little bored and decides to add a little entertainment to the program. After cautioning the student never to do this himself, he takes the controls. His routine begins with a rapid pedal turn, similar to what he did at the airport, followed by another Hollywood-style departure. He then pitches down into a long utility path cut between tall trees and does a high-speed run, nearly touching the ground as he followed the path. Manny was obviously enjoying this maneuver and looking for his students' approval. Once they approached the end of the path, Manny did an abrupt pull-up followed by a hammerhead-style turn to take another pass down the path. Manny then flew the aircraft back to the flight school base, where he quickly brought the helicopter into the parking area and abruptly planted it on the parking pad. He left the student to do the shutdown, exited the helicopter, and proceeded to the office so he could continue with his job hunting calls. The student really enjoyed this experience and believed it was the best flight he'd had so far. He tells this to a couple of his fellow student buddies and describes the details of the flight with great animation. Excited about his new helicopter experience, the student decided he wanted to fly some more and took an aircraft out for a solo flight. It had been a long hitch for this longtime company pilot, Grady, who was also a training captain and check airman. This was the last day of 21 straight days that included his regular 14-day hitch, plus an extra 7 days after his scheduled hitch. The company was short of qualified crews, needed the help, and Grady appreciated the extra money. His relief pilot agreed to come in earlier than normal so that Grady could make it to the airport in time to catch the last jump seat out for the day. But this day would be no different from the others, and Grady was very busy with differing assignments, including typical flights to rigs and various aircraft, training work that needed to be completed, and performing maintenance run-ups. Lunch consisted of nothing more than vending machine snacks, but he was looking forward to going home to participate in a family trip. Later that day, the dispatcher informs Grady of an urgent flight that was needed to take critical parts to a rig that had broken down, and he was the only captain available. The importance of this flight to the oil company is stressed, and they're anxious to get it working again. Grady called in a newly hired co-pilot, and they discussed the flight, which was a considerable distance from the base. The dispatcher did indicate that they had plenty of fuel on the destination rig. Grady figured that even with the distance to travel, if he departed within 10 minutes, he could still be back in time to catch his jump seat flight. Because of the past everyday routine with dispatchers and fuel availability and the shortness of time, Grady decides not to take on fuel at the base and just refuel at the rig while the parts are being unloaded. Although the co-pilot notices the lack of planning, he does not challenge the captain, nor did he bring the fuel sheet, missing Grady's request to bring it during all the rush. Anxious to get flying, Grady also goes against company policy and loads the heavy cargo with his co-pilot because he didn't want to wait for company ground personnel. Grady cuts short his walk-around and hurries the co-pilot. They depart for the rig. The trip progresses normally. The weather is good, the winds are calm, and they arrive at the rig at Grady's projected time. After a quick circle around the rig, Grady sets up his approach and lands. After removing the parts, Grady begins the fueling process only to be stopped by a rig crew member who advises that the fuel pump has broken down. Grady asked his co-pilot for the fuel sheet only to find out it was left at the base. Grady then rechecked his remaining fuel and distance from the home base and believed they had the ability to make it back with existing fuel on board. He also figured he could still make the jump seat if there were no other delays, and they departed for the base immediately. En route, Grady and the co-pilot kept a close watch on their time, speed, distance, and fuel burn. Although the margins were far less than customary, Grady still believed they could make the base with a small reserve. The co-pilot decided to plot a course for a rig that he knew had fuel and was much less flying time than direct to the base. But it would take them off course and delay their arrival to the base, and Grady would certainly miss his jump seat flight. Still, they pressed on, with the lightly loaded helicopter making good speed. With 60 miles to go and 345 pounds of fuel left, Grady nervously continued to convince himself that they still had enough fuel to reach the main base. It's midsummer in Alaska and the high season for tourist activity. The cruise ships were in port for the day, and tour flights were fully booked at this helicopter tour operation, which has begun its second season in business. Their business is a popular one because not only do they offer flight seeing over spectacular mountains, glaciers, and ice falls, they also combine the flight seeing with dropping their passengers on the glacier for trekking and camping. Although the tourists enjoy anything the helicopter company provides, the pilots especially enjoy the opportunities to get deep into the higher country, which is often restricted when the weather is low. During the past several days, the weather has been too bad to fly, and it was decided to take advantage of the downtime and do some scheduled maintenance early. However, on the following day, the weather unexpectedly began to improve, and the maintenance crews were immediately under pressure to get the work completed in a much shorter time period than originally anticipated so as not to miss any flights. An hour before the first group is scheduled to be picked up at the dock, the Air Tour Company dock representative arrived to meet the shore excursion manager from the ship to coordinate the day's departures. Due to the marginal weather and the reports of cancellations for the last several days, the shore excursion manager makes it clear if there's any likelihood the group will not be able to fly, she would rather reschedule them on another activity. The shore excursion manager also mentions that the other helicopter company that offers flight seeing trips for the ship's passengers is flying. After more assurances from the Air Tour Company representative, the group leaves the dock for the heliport. The group arrived at the heliport where they are outfitted and briefed for their glacier flight and trek. Dispatch is concerned that the next group is scheduled to leave town shortly, and they need to let the dock rep know if she should send them out or not. The shore excursion manager from the ship wants to know if the first group is going to fly on time, and threatens to cancel the rest of the departures and book her passengers on other trips if the tour flights aren't going to proceed as scheduled. The pilot, Jason, reminds the mechanic of the tight situation, and the final stages of the work is completed in a rush, and the aircraft is put back online in time for the tour flights. The shore excursion manager is informed to continue sending the groups, and the flights would proceed. The first group boards the helicopter. Jason does a cursory walk-around and then departs for the first of many scheduled tours. The flight began well, but the weather began to worsen with lowering ceilings and rain present. As the flight continued, the weather didn't change. However, an occasional small vibration in the pedals did get Jason's attention, but the passengers were engrossed in the ride, so he decided to continue the flight and have maintenance check it out upon return. Additionally, Jason, having been bored with not flying for days, decided to go to a special site in the higher country that he knew would really thrill his passengers, and it would be fun for him. As he got closer to the site, he encountered weather that caused more concern about terrain obscuration and whiteout possibilities. But he had promised his passengers to take him to this site and didn't want to back out on his announcement. His tail rotor pedals had settled down, and since he knew this area well and the landing zone was just over the next ridge, Jason decided that he could probably deliver on his claim to get to this special landing spot.
was an unrestrained passenger thrown from the vehicle. The patient is unconscious and unresponsive with blood coming from the left ear.
For nearly half a century, helicopters have been instrumental in saving lives due to their versatility and point-to-point speed. The survivability of trauma patients means that time is of the essence to most effectively utilize that critical golden hour. However, there is one factor that is more critical than time. That is the safe operation of the helicopter program. In this video, we will discuss operational and safety practices for the handling of helicopters at non-designated landing zones for the purpose of scene response. Utilizing helicopters for scene response requires consideration of distinct areas for planning and execution. These areas are preparation for arrival of the helicopter, ground operations, and departure. In the preparation stage, the important areas of consideration include the initial notification of the helicopter service and the actual selection and setup of the landing zone. Notification is usually the responsibility of the emergency medical service provider or law enforcement agency. The activation of the helicopter service should be considered any time an event occurs in which EMS or law enforcement believes that major indications for transport may be involved. You should familiarize yourself with the specific indications for the helicopter transport service that you typically utilize. However, some services may not accept patients due to safety and medical restrictions, which may include patients contaminated with radioactive or other chemical materials unless they've been properly decontaminated, patients that are violent, combative, or in custody unless they can be physically or chemically restrained, and patients that have CPR in progress. At the first indication that the helicopter service may be needed, it is important for the contacting agency to immediately relay the location of the scene so that the communication specialist can begin to plot latitude, longitude, direction and distance, and the pilots can perform the necessary weather checks in the event the weather is marginal. By doing this, valuable time is saved in the event the helicopter is ultimately needed. Upon confirmation by the contacting agency that the helicopter service is required, the helicopter will depart for the scene location. By this time, the contacting agency should have provided the communication specialist with the specific information required by that program. This information normally includes the number of patients, the approximate age of the patient, the mechanism of injury, if any hazmat operations are involved, and the radio frequency and identification of the LZ coordinator. Whenever possible, avoid the use of common frequencies and open PLs. This will keep radio interference to a minimum. Additional helpful information could include type of injuries, vital signs, and treatment initiated. If the contacting agency believes that more than one helicopter service will be needed, it is recommended that you allow the Helicopter Services Communications Center to coordinate this operation to avoid confusion and possible safety hazards. Preparation for the arrival of the helicopter service also includes the establishment of a safe landing zone. Critical to the setup of a safe and effective landing zone is the quick establishment of a trained landing zone coordinator. Only one individual should be delegated as the LZ coordinator. This individual should have the responsibility and authority to oversee and instruct the operations of all ground crews in accordance with their local helicopter services safety procedures. The LZ coordinator should also be the sole individual responsible for radio communications with a helicopter during arrival and departure. Here are the key items when considering a specific location as a landing zone: its proximity to the scene and accessibility, the size of the landing zone, the landing zone surface and degree of an existing slope, and any hazards in the landing vicinity. Although it is important to have the proximity of the LZ as close to the scene as possible, the LZ must allow for unrestricted accessibility, not only for the helicopter service, but for the ground crews as well. If the LZ coordinator determines that any surface restrictions such as fences, ditches, or soft ground will impede safe movement to and from the helicopter, another LZ should then be selected. Spilled fuel or broken glass can cause a significant safety hazard due to rotor wash, and therefore the LZ should be established well clear of these or other material hazards. Most helicopter services require a landing area of approximately twice the length and twice the width of the specific helicopter being used. However, the area surrounding the landing zone should be as large as possible to allow the pilot safe arrival and departure angles and room for maneuvering and avoiding obstacles. This is especially important for night operations. The surface of the landing area should be as firm and level as possible, with a slope of no more than that specifically indicated by your local helicopter service. Paved lots or trimmed firm fields make the best landing surfaces. Common landing zone hazards include wires and poles, towers and trees. When surveying a landing zone for possible flight hazards, we suggest that the LZ coordinator use the 45-degree test. By standing in the middle of the LZ, the coordinator raises his arm to a 45-degree angle. Any objects that appear at or above his hand line presents an obstacle hazard to the pilot, and they should be noted and reported. Additionally, for night operations, the entire landing area should be walked by ground personnel who raise and lower their lights to be sure there are no wire hazards in the LZ. The pilot should also be advised of significant surrounding features, such as tall transmission towers and water tanks, not only as a safety precaution, but to help the pilots in locating the landing zone as well. When using a GPS to determine the coordinates of the LZ, it is important that the GPS unit is cleared before a reading is taken, and that the reading is obtained while standing in the middle of the landing zone, away from any obstructions. These coordinates should be obtained and relayed to the communication center as soon as possible so that the pilots can establish the most accurate course. GPS readings obtained from inside a vehicle or standing next to a vehicle or other obstruction will most likely be incorrect. A compass should be used to accurately orient the LZ coordinator and pilots to the setup of the LZ, as well as the direction of the wind. The actual setup of the landing zone should begin with the LZ coordinator issuing ground crew assignments. Emergency vehicles should be placed at the perimeter of the landing zone, as well as under any wires with their lights flashing. Determine whether the use of items such as flares, smoke, crime scene, or caution tape to mark the LZ are accepted practices by your helicopter service. The LZ coordinator or a person assigned by him should stand at the point of desired touchdown with their arms raised and with lighted wands at night. For night operations, the vehicles should be pointed towards the touchdown point, their headlights on high, so as to form an X with the center at the point of desired touchdown. If available vehicles are limited in number, 2 vehicles pointing their headlights into the wind towards the center of the LZ is acceptable. As many flashing lights as possible should be used to aid the pilots in locating the landing zone, especially at night. Although ground crews may be able to see the helicopter approaching from a considerable distance, ground clutter and conflicting residential lighting usually prevents the pilot from spotting the LZ until much closer in. If available, blue law enforcement lights are especially effective in helping to locate an LZ. The landing surface and surrounding area should also be inspected and cleared of any debris prior to the helicopter's arrival. If fire equipment and crews are provided, all personnel should be at the extreme perimeter of the LZ to allow for the helicopter's full use of the space available. Onlookers should be directed to stay well outside of the LZ perimeter, along with all ground personnel not assigned a specific task by the LZ coordinator. Clear and concise radio communication is critical to a safe and successful scene operation. The LZ coordinator will be the primary contact with the helicopter pilots and needs to relay a thorough description of the LZ, including size, surface, slope, wind direction, and any hazards that may be present. Try to use a vehicle-based radio whenever possible, and don't offer any patient information until it is requested by the helicopter crew.
Guilford County, Unit 902, this is North Carolina Baptist Air Security, copy.
This is Guilford 902, copy loud and clear.
Roger, sir, good afternoon. We're about 10 minutes out from the LZ. Wonder if you had LZ information at this time, sir.
Roger. You'll be landing in an industrial facility parking lot, a paved parking lot. First hazard will be a light pole about 25 feet high. Next will be a fire truck on the west side of the landing zone. There is a chain link fence to the south side of the landing zone. No power line hazards in the immediate area. Then you have a light pole on the east side of the landing zone, and that's about it. It's a fairly open parking lot. It's been cleared of all debris and obstruction. The winds are from the north at about 15 miles an hour.
After relaying this information to the satisfaction of the pilots, it is recommended that radio communications be kept to a minimum to allow the pilot and crew to concentrate on preparing for the approach and landing. Should the LZ coordinator make audio or visual contact with the helicopter, he should advise the pilots and issue any corrective action the pilot may need to take to find the LZ. All heading change suggestions should be made relative to the pilot's point of view. Occasionally, a landing zone may be changed when the helicopter is en route to the originally plotted LZ. It is important for the LZ coordinator to advise the pilots of the new LZ location relative to the original LZ and be prepared to provide the new GPS coordinates if requested by the pilot.
The new landing zone will be a grassy area about a half mile east of the present location. We're currently setting up a landing zone. I'll have further information momentarily.
When the helicopter arrives at the scene, the pilot will usually circle the landing zone for a pre-landing safety inspection. All personnel should be cleared out from within the full perimeter of the LZ. All vehicles should be completely secured. Whenever possible, the patient should be secured inside of an ambulance with the doors closed. The entire helicopter crew has specific responsibilities during this phase of flight, which is why radio communication should be avoided unless responding to a pilot's request or you spot a dangerous situation. When the helicopter has turned on to its final approach, the person marking the touchdown area of the LZ should leave the landing area. Ground crews should direct their attention not to the approaching helicopter, but to the perimeter of the LZ to maintain security. All protective clothing, hats, visors, chin straps, and gloves should be in place and secure. Here you see a number of hazards caused by not following the guidelines. First, the trooper is outside of the vehicle in close proximity to the landing area. His hat was not secure and was blown away by the rotor wash. He is positioned between an open door and the vehicle, which could cause significant injury to himself as well as substantial damage to the vehicle or other persons or property if the door is dislodged. Another hazardous situation is allowing the patient to be in the LZ during helicopter operations. Once the helicopter has landed, the med crew will exit the aircraft. Upon exiting, they will proceed to the indicated location of the patient. It is not necessary for EMS, fire, or any other ground crews to approach the helicopter after landing, unless specifically directed by a flight crew member, and vehicles should never be allowed to operate anywhere within the perimeter of the LZ. The helicopter's tail rotor is extremely dangerous and can be difficult to see, and therefore must be avoided at all times. Any encounter with this component while it's turning will certainly be fatal. Assigned ground crews should continue to strictly enforce LZ security while keeping themselves well clear of the helicopter. For night landings, flashing lights, strobes, and high beams should be turned off when the helicopter nears the touchdown zone. Once the helicopter has landed and the crew begins to exit, searchlights that mark the path to the patient location are very helpful. Some helicopter programs will call another service provider to act on their behalf should they be busy or out of service. If this applies to your regular service provider, be aware that this may expose you to helicopter types and operating procedures significantly different from the helicopter and service you are accustomed to. Just remember that regardless of the helicopter type used, or whether it's a one or two pilot operation, all of the stated rules of landing zone security remain in effect, and it is absolutely critical that you do not approach the helicopter unless directed by a member of the flight crew. Upon landing and exiting of the aircraft, the helicopter service's medical crew will assess and prepare the patient for flight. EMS or fire personnel will usually be designated by the medical crew to assist with the moving of the patient to the aircraft. Unless patient circumstances creates a prolonged ground time for the medical crew, the helicopter rotors will usually remain turning. This creates a number of safety issues that must be considered. Main rotor wash can cause loose debris, clothing, sheets, and any other unsecured material to be blown into ground personnel or the helicopter itself. And the helicopter's turbine engines are extremely loud and therefore make normal conversation between ground personnel nearly impossible. During loading under the direction of the helicopter crew, the patient will be taken to the aircraft. Notice that no objects, including IV bags, are held up in the air where they could be hit or blown away by the rotors. The patient is positioned at the helicopter for loading and then lifted into the aircraft. Specific ground personnel charged with moving the stretcher are also responsible for securing the sheet if provided. After the patient is in the aircraft, all assisting personnel should immediately move to a safe distance away from the aircraft, secure their equipment, and close all doors. The helicopter crew will take responsibility for securing the patient and the aircraft. For those helicopter programs capable of carrying more than one patient, the loading process should be nearly identical to the one-patient scenario. It is important to note that all assisting ground personnel assigned to a particular patient leave the helicopter area once their patient has been loaded. Only those ground personnel assigned to the additional patient should assist in the loading of that patient. At no time should any ground personnel return to the aircraft unless specifically directed by the helicopter crew. When loading additional patients, it is often necessary to circle around the helicopter. This should only be done under the direction of the flight crew and in accordance with the specific procedures for the helicopter being used. Should the helicopter service be required to transport more than 2 patients, special procedures are involved for the setup of this operation. Just remember that you're never to approach the aircraft without explicit direction or approval from one of the flight crew. And once your specific task is accomplished, immediately leave the helicopter area. If 2 helicopters will be using the same LZ, the pilots will assume the primary responsibility for coordinating their operations. Ground crews should stay well clear of the landing area and watch for any unsafe ground movements. Helicopter ground operations with the doors open and crews in LZ will occur only when both helicopters are either on the ground or when one of the 2 aircraft has safely left the LZ. Patient transfer to the helicopter should always occur around the front and well clear of any other helicopter in the LZ. And all ground personnel should quickly leave the area and secure their equipment once the patient is loaded so that one or both of the helicopters can depart. During all scene operations, the LZ coordinator should enforce strict traffic control around the aircraft. Common landing zone security problems experienced by helicopter crews include family members of the victims at the scene, news crews, and onlookers who are not staying back the minimum distance specified by your particular helicopter service. If necessary, the LZ coordinator should appoint extra EMS and fire personnel to assist with landing zone security. During helicopter departures, it is critical that you confirm that the entire LZ area is secure, equipment is stored, and all doors are closed. Here you see a number of hazards caused by equipment remaining outside of the ambulance and the doors remaining open. For night departures, high beams and strobes should be left off. The flashing lights used to mark hazards should remain on. Do not attempt contact with a helicopter during departure unless a safety hazard is observed. The number 1 priority of any helicopter service is safety. Scene work is the area of operations where EMS helicopter programs are most exposed to unexpected hazards. By following the guidelines outlined in this video and specified by your particular helicopter service, you can be most effective at helping that service minimize the risk of scene response hazards.